So these numbers on the periodic chart, right? We know that's our number of protons. We know the column tells us our charge, right? Everybody in column 1 gets a +1 and that kind of stuff, right? This periodic chart even has it written there for us. These numbers at the bottom are the average of all the isotopes that exist if you're talking about one atom, right? So if you've got one atom of sodium, it would not weigh 22.99, but the average of all the sodiums would be 22.99, right? One sodium would be 22 or 23 or 24, right? Different isotopes. But if I have a whole mole's worth of them, a mole's worth is 602 hexillion, right? So that's so many, it's going to be the average of all of those, right? So these numbers are true in grams with the mole. So if I have 1 mole of calcium, it would have a mass of 40.08 grams. If I have 1 mole of potassium, it would be 39.098 or 39.1 grams, right? I always recommend going to 2 decimal points. I believe that's what your periodic chart does. Yeah. The orange periodic charts that I gave you, those already round everything to 2 decimal places. But we can use those then to see how much we've got, right? So counting by weighing, just like we did in the lab. So if I've got, let's say I've got 32.6 grams of sodium. So this is a measured amount. So these are 3 measured values. So that's how much precision I have. So my answer should have 3 measured values when I'm done. If I want to know how many moles that is, right? Because moles is a count amount instead of a measured amount. If I want to change that to a count amount so that I can do something like stoichiometry or just know how much I have, then I use that molar mass off the periodic chart. So I just go to my periodic chart and I see sodium is 22.99. So it's 22.99 grams of sodium for every 1 mole of sodium. That's one of the reasons I like to go to 2 decimal points, 2 places after the decimal. Now this is a measured value, but it's 4 digits. Well, I always go with the least when I'm doing calculations. So if I've got 4 measured values here, 4 significant figures, and 3 here, then my answer gets 3. So I don't have to think about it a whole lot if I just tend to use 4 there. That's going to usually be more than I'm given. So I set it up so that they cancel. Since I've got grams, I put grams down here and moles up here. So my grams of sodium cancel out. 32.6 divided by 22.99. And that's going to give me 1.4. I'll write a bunch of digits. This is what y'all tend to like to do. And that's mathematically accurate. But if I used a scale that was accurate to 3 digits, then really I have 3 digits of accuracy here, right? So I'm going to say 1.42 moles of sodium would be the best way to answer that, right? Let's do another one, right? Let's go the other direction though. Let's say you know an amount you're going to make of something or whatever, right? Let's say you know you've got 0.0362 moles. Who should we use? We'll use iron. We've got that many moles of iron and you want to know how many grams that is. Or maybe you don't want to know. Maybe you could care less, but I'm asking you, so you kind of have to figure it out, right? Because life's fair. So what do we need to do? Can we use the 22.99? Can't use the 22.99. That would be like using the average weight of a paperclip and then learning about cars, right? Well, cars and paperclips have a different average weight. 12 cars is the same count as 12 paperclips, but they would weigh very different amounts. So 1 mole of iron and 1 mole of sodium is the same count, but they would weigh very different amounts because the size of each atom is different, right? So, so we can count by weighing, but we have to know what each thing is. So I would use the molar mass here, and the molar mass I would use would be iron's molar mass. So 55.85, right? We find that on our periodic chart, 55.85. And then I say, well, would the 55.85 go on top or bottom? Well, 55.85 is grams for every 1 mole. So if I have moles here, then I would say, well, for every 1 mole of iron, it's 55.85 grams of iron, right? So I cancel out. So notice it's flipped. Now, some students will want to memorize that, but if you just get used to that process, you don't have to memorize, oh, well, when I go from grams to moles, I do this. And when it's just so easy to forget when you set things up like that. If you just get used to putting the units out, it's a lot easier. So 0.0362 times 55.85, and that's going to give me this value here. And again, I've got 3 measured values. That's like a placeholder 0, right? I've got 3 measured values, so my answer should have 3 values. So it is 2.02, right? Because that would be 3 measured values there. So hopefully that helps with those.